So let's continue with the second part.
Yeah, cool.
So yeah, this will be very similar. I will show you some very basic examples, the most basic minimal examples possible.
That's perfect.
So burst, and this is very related to the previous topic.
Yeah.
So a burst is a compiler that takes your C# code and converts it into highly optimized native code. But if you want to see it more technically, it's a transcoder from .NET Intermediate Language, IL, to LLVM Intermediate Representation. So your C# code is transformed to IL always, because C# is for humans, for humans
it's
reading it.
Human readable code, right?
Yes. And this IL is a version of your code in C#, but with a way of writing it much more better for the compiler.
Right. Because let me just make a quick pause, because we know that some of our users probably, and they don't need to know about compilers and stuff like that, right? Because we want to make games, we don't want to make necessarily compilers and know about this, but the code that we write, either C# or previously Unity script or those languages, that code is not the code that the machine runs, right? Because that code, it's, as you said, it's easier to understand for you humans, but it's not something that is optimized for the machine. So at the end of the day, the stuff that it's run on the device or on any platform is machine code, and is not our C# code. And all the process in between, well, we don't necessarily need, or I don't know, but people don't necessarily need to know like the specifics if they don't want to, right? So
yeah, exactly. So this is more like a note if someone is more interested in a bit more technical description of this. So this IL language that's not new. That's something that always happened from the start of Unity, and is something that always happens when you are programming with .NET, not only C# but any .NET language. It will be transferred to this IL. So that's old. That has been like that since ever. But the next part, that following part is new. That we are using the LLVM, which is an open source project for creating compilers.
Okay.
So we are using that. Like basically, we are not reinventing the wheel.
Yeah. That's what we tell our users, right? Like, don't reinvent the wheel, and we follow that as well. Like, if there's something good out there, then we are going to use it.
So this LLVM project is a really huge thing that we are using here. So that's the idea, and of course you can read more about that in our documentation. There are a lot more information. Okay, so this is suite for data-oriented design, which is another of the pillars that we are moving toward, and this is intended for only the critical code in your project. So it's not the idea that you will use parts for absolutely all of your code, but just for those critical parts, basically the code you run on every frame.
Why is that? Is there like a reason for that? Is it too slow to generate the code? Or?
It's the vision, the objective that the team has. It's just that, because if you will include all the code on your game, you will need to have other considerations like build times and etc.
Okay.
So that's a design decision.
Okay. Okay.
But it's cool because it's the code you actually need to optimize more. So it's a good compromise.
Mm-hmm. Yeah. Good.
So it uses single instruction, multiple data, or SIMD, and it's basically that's the basis of birth.
Okay.
So basically, this means that you can apply the same operation to more than one set of data in a single CPU instruction. So things will be faster when you can use SIMD. In theory, it can be as fast as C++, but with much less effort from the developer. So yeah, for achieving the same kind of performance in C++, you will need to do a lot of setup and move parameters, and it won't be easy, but with Burst it's very easy. You will see it's ridiculously easy. But this is a very interesting point, because a big part of Unity is written in C++ currently.
Yeah.
But it was because of performance. But if you can write code as performant as C++ in C#, we should do it. And that's basically the plan.
Yeah.
So the current plan in Unity is to start writing as much as possible in C#.
Right.
And we know it will perform. It will be very fast code, perform very well.
Right. And that's why we like the new package manager. Everything there is just C#, right?
The idea is to make the source code available.
Okay. Cool.
So yes, so all that C# code that Unity will be writing in the coming years will be available in packages.
Okay. Awesome.
So a few more details. It supports only basic C# types. So something very similar to the thing I was telling you about the jobs, that they use those primitive types only. This doesn't support any managed objects. And currently, you can use Burst only to optimize your code inside jobs.
Okay.
But there is a plan to make it available for any code, in your project. But as I say, probably not all the code in your project, because you really don't need to optimize all your code. Or I mean, you don't optimize things that will run only once. Yeah.
Yeah, as you said, you have to make compromises. Like something might not be worth a build time versus the improvement you will get somewhere else. Right?
Yeah. So basically, the code you have in your update loops that executes every frame.
Okay.
That will be the code.
Okay.
That you will want to optimize. So yeah, this is a work in progress. So it only supports the editor and standalone. This is a package in the package manager. We're planning for a first official release in 2019. Yes. So let's see the examples. This is very similar idea to the previous part. So I have here. This will be my first example. So what's the idea here? I'm adding a lot of values that are on an array that I call A, with values in B, and assign the results here. And we'll be doing this a million times.
Okay.
So we have these arrays to store those values, and this is the old way of doing it. So no jobs. So that's why I'm using normal managed arrays. Yeah, I'm setting some random values there in those arrays. And I'm doing the addition here. And that's all I'm doing here in this script. So the result for that, from that, with a million additions there, yes. Is this. So it takes about 3 milliseconds, which is not that bad, but it's not something you will do on a video game, because it's
yeah. This is a theoretical case, right? But it helps us understand.
So this will be slow for a frame in a video game.
Yeah.
But as I said, I can't use bursts yet.
Because you're not using jobs.
Exactly. So next example is actually using a job. So we can see that. Yeah, so this is very similar to what we saw in the previous example. So I'm now using an iJob here. And I added this note here that I'm also doing a for here. So it would be better to use parallel for, but I will do that at the end. But not yet, because I wanted to run this on a single thread to be able to compare the code with and without burst optimization running on a single thread.
Okay.
So this will allow us to compare. But in real life, you will use parallel for something like this. But yeah, it's very simple. Again, it's a native array because I can use managed arrays. So again, I'm using native arrays for my 3 arrays. I'm doing the addition here. And I'm repeating this a million times. And here I'm just initializing stuff and setting random values there. Yeah, and I'm running the job here. So this is very, very simple code. So, okay, another thing to note is that we're already using bursts here.
Yeah.
That this is the only thing you need. So it's very, very easy.
That's the only thing you need to add to compile with burst.
Yeah, okay. Exactly. So you have your job and you add this attribute, and yeah, that's all.
Okay, sounds good.
It's now optimized. Yeah, so with just that optimization, it went down to this time, which is like 30% faster, because it was almost 3 milliseconds, and now it's 2 milliseconds and something. So yeah, it's a very good.
Yeah,
very good gain there just by adding an attribute.
Yeah, definitely. It's worth taking 2 seconds to type a burst compile there.
So okay, you need the burst package that you can just find in the package manager. It's called burst. So you should be able to find it easily and add it to your project. And that package will add this menu here. So there are a few interesting things there, like these ones which are for options for the optimization that we'll see in a moment. And this is a very interesting tool here. It's called the Burst Inspector. So here you can see the jobs that are optimized in your project. So in my very simple project, I have these 4 example jobs that I'm optimizing, and I can select one of them here and see the code. So this is very cool. And yeah, you can see here the code in the different stages. So for example, you can see here .NET IL code that I was talking to you before. And yeah, so the idea with this is to debug and to understand what the compiler is doing. And this is a primitive version of this tool. The idea is that you will be able to have like a side-by-side with each of these stages. So you can select a few of your lines of your C# code and see those lines, how are those lines translate to IL and then to the intermediate representation, but not optimized yet. And then what happened when the optimization runs over that code. And yeah, so currently it's not very easy to follow that that process here. It currently requires a lot of time of reading and understanding this generated code. But yeah, that's that it will be very easy, and it will allow you to debug, to know why the optimizer is not doing what you expect. So the idea is to show you like kind of tooltips or that kind of help that say this optimization was not possible because of this reason. So yeah, there are very big plans for this tool.
Yeah. I mean, just seeing this, it's super exciting to being able, like, again, not every Unity developer probably needs to use these tools, but if you want to, it's great to have this control. It's great to have these tools and the guidance on how to optimize.
And it might happen that you actually have code in your frame loop that you need to run a million times, like in this example. But it could happen on your game. Absolutely. Maybe. So those few lines of code that run a million times every frame, you definitely want to see what's going on here, how is the optimization going, and what you can do to optimize better.
Great.
That code. Awesome. So you see, it's very, very focused on that critical code of your project. So next example, there one of the options in the jobs menu is called safety. And when I disable that safety option to make the optimization more aggressive, you can see this is actually amazing.
Yeah.
How fast is it now? So we were in over 2 milliseconds. And now we are just over a half millisecond. This is using something called, let me show you it's just this check. I disabled that for that test. And that gave me this this improvement.
Interesting.
So it takes advantage of this thing called no alias, which is explained in the documentation, in the Burst manual that is available. So you can read more about that there. But basically, that allows to operate over 4 sets or floats on every CPU instruction, which is the SIMD that I talked, and also called auto vectorization. So basically, it has to do 4 times less CPU instructions. So you can see it's more or less 4 times.
Takes 4 times.
4 times less time. So this 4, that number, it will depend on the hardware. But in the hardware I was running on this laptop, it allowed, the CPU has registers to set 4 for those sets of results. First, but the first value you are adding and the second value you are adding and the result. And for four of them, they fit on the registers of this CPU.
Yeah.
So that number 4 will vary depending on the CPU you are running. But yeah, it's impressive, I think.
Yeah, it is.
Yeah, but not always. So this no alias optimization is not always possible to apply it, but in this case it was possible.
Okay. But it's good to know there's an option. Each person needs to evaluate either
sure
they have to use it or they can, etc. But
yeah,
it's good to know that it's possible.
And there are more options that you can define in that attribute that you set in the job. You can add options there. So there are options, for example, for the accuracy of the calculations. So if you know that you don't need much accuracy, you can set the lowest accuracy and it will optimize more and be much faster. So yeah, that's very cool. Also because it's not easy to do that, for example, on other environments like on a C++ project. It's not that easy
to
do that kind of thing. Here you can, for every job, you can set optimization options. It's very cool.
Nice.
So now I wanted to do, we were doing only a single addition, which was very, I wanted to do something more heavy on every cycle of that loop. And I just did this. So this, the idea is very similar. So I have an array A, an array B, and the results. And but this time I'm doing operations with matrices, and this code is only for assigning random numbers on those matrices. It's very, very simple. And here in my update, I'm doing here some crazy operation. Because I just wanted to have hundreds of.
So you are taking the inverse of the inverse and multiplying that by the inverse of the other matrix.
Yeah.
Right? Okay, cool.
Yeah. So basically, I just wanted something that I could write very easily here, and will generate like hundreds of. Of operations that actually you can confirm here that let me show you that this actually, like, for example, this IL code, this hundreds of operations going on there. Yeah. So what happened there? This doesn't use jobs, like the first example. So no jobs and no burst. And it takes 700 milliseconds to do a million, that crazy operation, a million times.
Okay, yeah.
700 milliseconds is absolutely not. You can't do that on your game.
No, of course not. No.
Definitely not. But yeah, let's see what happens when you start to optimize that. So I add burst to this example. So that will be this one. So same thing. I created a job.
Yeah.
This all the same code, and I'm just running that job in my update, and the job code is exactly the same, the same inverse thing. Yeah, but it's optimized with burst.
Yeah.
So that make it like it was 700, and it's now 187. So it's much faster. like a really, really big difference. So this is us using bursts and a job. And well, in this case, that no safety optimization that worked great on the previous example, this time basically didn't have any effect. So that's why I was telling you that not always it will will work that way. It's because the alias that, well, it depends on the layout of the data, and in this case, it was not applicable for this case. So but we can improve that with the new math library.
Okay.
So this is a math library that takes advantage of SIMD, which is the normal math library. The old one doesn't do this.
Yeah.
The syntax is similar to the shader language, HLSL, or to most of shader language, and because those languages were created with SIMD in mind from the start. So you have types at float for int for that you will recognize if you have experience with shaders.
Which is the language we are generating with shader graph. HLSO.
Yeah. So shader graph uses one of those shader languages that were designed from the start to use SIMD. This is based on this open source project called Sleeve.
Okay.
So if you are curious, you can find that project freely. And this is meant to be used with the burst compiler, so you could use it without burst, but you won't have any interesting results really.
Okay.
This is also a package, the package manager, and it's also experimental as the other one. Okay, so what happened when you use that math? Okay. So let's have a look at the code. So the code is a bit different because now we are using this new namespace, mathematics, and the way you write the code is similar but a bit different. So in this case, if you remember, I was using this math library that is included in the matrix for X4 class.
Yeah.
For example, this inverse. So I transformed that to the version of the math library, and just replace. So that matrix multiplication, I replaced that with this multiplication
right,
and the other inverse. So this code is hopefully doing the same thing as the previous example.
Yeah.
But the rest of the script is the same. So I'm still using native arrays. Everything is basically the same. Just executing my job in update. Just for doing that change to the old math library to the new one, I reduced that time to 30 milliseconds.
From 700 now we got to 30 milliseconds.
Which is very, very amazing. But remember, we are not using the job parallel 4. We are still running this on a single core, which is not what you will do in real life.
Yeah.
So as a final example, I did use that. So I replaced the iJob with the parallel job, and it was reduced again to just over 9 milliseconds. So that's 77 times faster than that first example. And that first example is what is the way you would program your game today.
Yeah. Okay.
It's just that. It's the way you program today in Unity.
Okay, nice.
Before using all these new technologies. So it's very, very amazing, I think.
It is. It's impressive because, as you said, like, we can get huge speeds using C# without having to go to C++ or things like that. So it's crazy. It's pretty impressive.
Yeah, and it's very easy to use. All these technologies are very easy to use. So you can change very easily your old code to the new way. So as a conclusion, this is a combo. Jobs, birds, the new math library. When you use the three of them, your code will run really fast. And yeah, you will need also this is another piece of this puzzle.
Yeah, the entity component system.
The entity component system. You most likely you will need to use ECS in your project to be able to use those other technologies like in a practical way.
Yeah.
So everything goes together. And okay, for more info on bursts, there is a manual that you can find here in this link. And there is also a video, very recent from the United LA. And this one of the creators of bursts gave a talk.
Yeah.
And yeah, if you are interested in details, you have to check that video.
Awesome.
That will give lots of details about burst. And that's it.
Okay. So thank you very much, Juan, for being here with us, for sharing your knowledge. I appreciate your time, and I'm sure all of our subscribers appreciate this as well. You want to say goodbye?
Yeah. So thank you again for inviting me, and yeah, I hope this was useful.
It was.
Yeah. Okay.
Okay. Thank you.
Bye.